discovered? So in 1785, Charles Coulomb charged body spontaneously loses its charge. Spontaneously loses its charge and people are not able to understand that what is the reason behind that. Then Faraday and Crookes showed that if air is removed from around the charged body, the rate at which charge was lost, charge was lost decreased. So that means if air is removed from the charged body, around the charged body, and this was done in the vacuum tubes. So if air is removed from the, say if it is a vacuum tube and if air is removed and here is some charged body, then what they observed that the rate at which charge was lost was decreased. So that means with the removal of air, this causes the decrease in the charge. So that means air is ionized, right? Air is ionized, and when the concentration of air gets decreased, that means the rate will also gets decreased. So that means there is something in the air. This suggests that there is something in the air which is causing ionization of air. But we do not know that what is it which is causing, and experimentalists cannot control it. Mentalists cannot control it. Then, to provide the answer to this question, Becquerel's radioactivity provided the answer. Becquerel's radioactivity provided the answer. Provide the answer to this question. Means radioactive radiation radiation coming from the Earth's crust may cause ionization of air. Right? So this is the one of the possible answer to this question. This was the suggestion at that time. So but to test it, CTR Wilson performed the experiment inside the tunnel. As tunnel is surrounded by rocks, so there is a possibility of more radioactive radiation. So that means there must be more ionization of air. Must be there inside the tunnel. But this doesn't happen. This doesn't happen. And another thing which was observed that ionization rate increases with increasing height. Increases with increasing height. So in 1909, Theodor Wolff developed a electrometer and tried to find out the concentration of charged particle at the Eiffel Tower. So say this is the Eiffel Tower. So he performed the experiment, and this is the 330 meter is the height of it. So what he observed, the ion concentration is larger, or ion concentration increases as we move up, means ion concentration is larger than the bottom. This was observed. And similar type of observation made by Domenico Pacchini in 1911, right? So due to these observations, people concluded that ionization must be due to ionization must be due to some source, some other source, means it must be other than radioactivity, right? Then in 1912 Victor Hess carried electrometer to an altitude of 5300 meter, means roughly 5 kilometer above the ground, in a balloon. And he found that ionization rate increased approximately 4 times over the rate at the ground level. So then it was assumed that initially it was assumed that sun is the source of radiation which causes ionization. So to confirm this fact, Hess has taken the observation on full solar eclipse. But he still found the same observation. Let me briefly talk about it. So if radiation is because of the sun, then on solar eclipse it is the sun, it is the moon, and it is the earth. So it will block the radiation coming from the sun. That means it was expected, if it may be because of only the radiation because of sun. So if it is only the possible reason for the ionization, then it must decrease on the full solar eclipse. But this doesn't happen. So that means ionization, the reason for ionization will be different. The reason for ionization will be different. Also, in 1913 and 1914, Werner Kohlroster confirmed the observation made by Hess. So thus Hess concluded that on the basis of his experiments, Hess concluded that these were radiations penetrating the atmosphere from the outer space. And later Robert Andrew Millman Millikan in 1935 he called these radiations as cosmic rays. And Hess got the Nobel Prize. Victor Hess got the Nobel Prize in physics. Hess got the Nobel Prize in physics in 1936 for cosmic rays, for the discovery of cosmic rays, right? So this is all for this history of cosmic rays, or we can call it as the beginning of cosmic rays. So that's all for today's lecture.